Hi, for today's video, I'm going to answer 5 random questions from subject Advanced Math. So let's start. So for the first question, we're going to answer simple matrix, multiply matrix A and B. So this is the matrix A and B. So the matrix A is 2, 2, 4, 6, 1, 3, 5. It is a 2 by 3, 2 by 3 matrix. And matrix B is 7, 9, 8, 10, 11, 13, and 13. And this is a 3 by 2 matrix. So what gonna be doing here? So we're going to multiply I have pattern like A1, A2, A21, A22, A31, A33, and here I will going to put what is the value that we will be going to multiply. So first we get 2, 7, 1, 7. So 2, 7, 1, 7, and plus. So we have now 4, 4 and 8, 3 and 8. 4 and 8. Sorry for my handwritten. 1, 3 and 8. 7 plus 6 and 11, and 5 and 11. 6 and 11, and 5 and 11. And next is 2 and 9. And 1 and 9. And then so what is next? So 4 and 10. 4 and 10. And 3 and 10. 10. Next. So last is 6 and 12. 6 and 12. 6 and 13. And 13. And 5 and 13. Row 3, column 2. 13. So we were going to times the values that we have here. So let's calculate. For 2 times 7, we have 14. And 1 times 7, we have 7 plus 4 times 8, we have 32. 3 times 8 are 24. 24 plus. And 6 times 11, we have 66. 66. And 5 times 11, 55. For the matrix B, 2 times 9, so 80. 1 times 9 times 1, 9 plus, sorry for my handwriting. So 4 times 10, 40. 3 times 10, 30. So 40 and 30. And 6 times 13, we have 78. 78 plus 5 times 13, we have 65. So now, as we can see, we have 2 by 3, 3 by 3, and 3 by 2. First and outer number, that is the output here. So we have 2 by 2 output here. So A and B, A and B is equals to 114 plus 32 plus 66 is 112. And 7 plus 24 plus 55 is 86. And 18 plus 40 plus 78 is 136. And 9 plus 30 plus 65 is 102. So this is the matrix A and B multiplied. So we have right now 2 by 2 from 2 by 3 and 3 by 2 matrix. This is the answer. So next, for the question number 2, we have here two complex number, complex A and complex B. So complex number A is 3 plus 2i. And our complex number B is 1 minus 4i. So in this particular solving, we're going to multiply. So first, we can use FOIL method to easily multiply the values. So 3 plus 2i, 1 minus 4i. So 3 times 1 is 3. And 3 times 4i is 12i. Yes. And 2i times 1 is 2i. And 4i times 2i is 8i squared. So next, so after the FOIL, we have here now that 12i and plus 2i equals 2. So I squared so is equals to -1. So 8 and -4. We have -1 here. And we're going to change the sign to I. So we're negative plus negative is equal to plus and plus 8. And now we're going to add the value. So 3 minus 12i plus 2i plus 8 is equals to 11. 10i. So here is our final answer. So next. So for the question number 3, we're going to solve system of linear equation using Cramer's rule. So this is the equation. So negative 5x, negative x, 55y, negative 2y, negative 3y, and this is 4. Minus z plus 2z. This is 2 equals to negative 21, negative 22, negative 11. So what are we going to do first? So first we're going to find the dominant value, or I mean determinant value. So we're going to input the values to find the determinant. We have negative 5, negative 5, negative 4, negative 3, negative 1, negative 1, negative 2. So here. So the pattern that I'm using is like this. For the A1, I have the -5, -5, and -4, -3, -1, +2. No, is +2, +2, and for B2, that I have already. So this is again, so -5, -5, -5 for this, because we have negative sign in the equation. So the left side and the right side, we're going to get -5, -1, -1, and 2. And for the last, AC, we were going to have like this reverse of the first L. So our value here is plus -1 and -5, -1, -4, and -3. So like that. So if we going to solve this equation, we're going to get the determinant -11. So that's it. That is the answer. That is the determinant of this equation. So next, we're going to find the dx. So just like we do in the determinant, we're going to find the left side L first for the A1 and the letter T and the reverse L like this. So I forgot. We were going to put the values here if we're going to look for X, Y, or Z. For example, we have here, we're looking for the X. So we're going to put the values here, -21, -22, and -11. And next for Y and Z, we're going to input the default value for them. So, -4, -3, -1, -1, 2. So if we're going to solve it like this and this, we are getting the value of -66. Sorry. Yeah, -66. So for the dy, just put again the value. So in the middle for y, 22, -11. So -1, -1, 2, and -5, -5, -1. And L, P, and reverse L. That's what I call that. And if we're going to solve that again, we're going to get the value 11. So for the dz, again, we're going to put the value here for the specific. If you're looking for z, so we're going to put here the 22, and 11, and the default value here on the left side for x and y. negative 5, negative 5, negative 5, 5, negative 5, negative 1, 540, negative 5, 4, 3. So it's like the other three. We're going to solve like this, the LT and reverse L forms. And if we're going to solve that, we're going to get the value 44. So now we have the value for x, y, z, and the value of the determinant. So we have this formula that we are going to divide the x on the determinant dy, or for dy, d, and dz, d. So what is the value for dx? We have negative 66. And for the determinant, negative 11. dy 11 over 11. And 44 over negative 11. So we're going to calculate negative 66 over 11. So we have like 6. So for our x is 6. For letter y, for y, 11 over negative 11 is negative 1. Negative 1. And for the z, we have 44. 44 over negative 11, so we have negative 4. So for this Cramer's rule, we have the answer for x, y, z, 6, negative 1, and negative 4. That is the final answer. So we can check that in calculator. I'm going to input first the values. 5, 2, negative 5, negative 5, negative 1, negative 21. Sorry. Negative 5, negative 5, negative 1, negative 21, negative 5, negative 4, negative 1, negative 22, negative 1, negative 3, 2, and negative 11. So for the value for x is 6, y is negative 1, and z is negative 4. So we are correct. So next question. Go to our space. More space for our solutions. So next, I'm going to put it. So for the fourth question, we have here Gauss-Jacobi. So we're going to solve this linear equation using Gauss-Jacobi. So first we're going to check if the equation is diagonally dominant. So in this scenario, this is diagonally dominant. So we're going to proceed in substituting the values. So for x, we have 4 minus, I'm going to remove it, I can see the values, minus 1y, because we only have y, and plus 1z, because we only have z, and for I over 2. I'm going to put that in. Like that. Over 2. So for y, we have 7 plus 1x, we don't have value for x, and negative 2z over 3. So for the z, we have 1, negative 3x, and plus 2y, and over 5. So now we have here the substitute value. So now we're going to proceed in iteration. So iteration. So we're going to start at 0. 0, 0, 0. So for now, I will going to present the how can we substitute the value. So for now, we have x, y, z, so we have 0, so we're going to substitute that. So we're going to put 0, 0, 0, 0 for the x, y, z, so 0, 0, 0. So if we compute that, we're going to get the values for x, y, z, and we're going to get the value for x is 2, for y is 1.4, and for z is 0.2. So in this particular iteration in Gauss-Jacobi, the difference of this method to Seidel is in Seidel, in every process of iteration, if the x is updated, we will going to put that after or on the process of iteration, not in every iteration, in every 1 or every 2 iteration. The value is updated in every step. So that is here. If we have x here updated, we're going to put the value of updated x here. So they're not the same like here. If we have 0 here, we have 0 here for Jacobi. Yes. And next, I'm going to erase the 0 first. We're going to put another value for that. So for the second iteration, we're going to put new values to them. So for y, we have 1.4. For z, we have 0.2. For x, we have 2. For z, 0.2. For y, 1.4. For x is 2 again. So just like that. And if we're going to compute that in calculator, we're going to get the values 1.4 for the x, 2.866, negative 0.44 for z. So just like we do in the first iteration, we're going to substitute again the values. So there's no exact or needed iteration number. So for this method, this is only an approximation, or we can get the exact iteration number, or we can predict if we're going to iterate 10 times, 20 times, or 30 times, or and so on. And for some instances, it will be going to 100 plus. So for now, I will going to stop at the second iteration, and the values I will show the fifth iteration, so we can get a value nearest to the true value of the equation. So for the fifth iteration, I get 1.559, 1.749, and 0.628 208, sorry. And for that, the value is almost the same or near to the true value. This is the Two answers, so 0.7. Also, it's nearby, it's slight near, or we can round it up. So 1, sorry, 2.357. So for the y, it's not so. So for the y, it's not near at all, but we run at the 2.866. So I think if we're going to iterate more, we're going to get the nearest possible value for 2.357. So for the z, we have 0.5. So 0.5 and 0.628 is almost near. So this is our answer, and we cannot get the exact iteration needed for this equation because this is only an approximation. Okay. And next, so for the fifth and last question, we have here a complex number a and b again, but now we're going to add them. Addition. We're going to use the addition. So we have for complex A, we have complex number A, we have 4 plus 2y. That's 2, right? And for the complex B, negative 1 plus 3i. So what are we going to do here? So we're going to separate the real and imaginary numbers. So we're going to put the count minus 1 and 2i plus 3i. So 4 minus 1 is 3. We have here 3. And for the 2i plus 3i, we have 5i. So this is basic addition for the complex number. So this is our final answer. So for the additional question, we have the subtraction of the complex number. So we have here a and b, complex number a and b. We have the value 7 plus 1, 3 minus 4 plus 2y. So for this, we're going to subtract only the value. We're going to separate first the real and imaginary numbers. So we have here 7. We have here the 4. 7 minus 4. And for the imaginary numbers, we have 3i. And we have 2i. So minus. So our answer is 3 plus 1i, or 3 plus I for simplification. So this is our final answer. So that's it. We answered 5 random questions from the advanced math subject. So I hope you have a good day, everyone, and thank you.